Good afternoon, everyone. I'm Rachel, and I'm a second-year statistics student here at the University of Warwick. And before that, I actually did my master's at Warwick a while ago, and then I took 3 years off to go work in social work, which was kind of a weird life choice, but it gave me the chance to work with lots of different data sets that I wouldn't have been exposed to otherwise. And so I worked in food insecurity, and so at a really interesting nonprofit that was part academic. We were part in the public sector, part in the third sector, and so this project that we did had to do with these different federal nutrition meals that we have in the States for getting meals to kids in the summer. And so what we found was that a lot of these sponsors who were serving the meals often weren't financially viable. Um, and we wanted to know why. So in conjunction with the Walmart Foundation and the Texas Department of Ag, we went out and visited with these sponsors and then used expert elicitation techniques to come up with a Bayes net. And this was sort of guided by Martine, who's going to speak to you about Azure at some point. And so what this enabled us to do was to do some just decision analysis. And so we could come in and try different policy interventions. So in this, we were saying, okay, what happens if we make the menu quality better, or if we put more flyers out in the neighborhood, increase the media, or if we lower the administrative costs? Which one of these should we focus on? Because often our sponsors had, I think a lot of third sector people can relate to this. You don't have a whole lot of resources, and you need to make sure they go to the right place. And so then in the background, we would do we'd set a utility function on all of this, and then we were able to optimize the policy. And we got to present this to the Ways and Means Committee, and this was all really good fun until I got to the point where I realized I had a lot of problems that just I couldn't slap a Bayes net on. So I mean, this I could do with my master's, but then I really wanted to do more theory. And so at that point, I came back to work with my supervisor Jim Smith, and that got fun because all of a sudden I realized there's lots of other different models that we could come up with that don't have to be a Bayes net, that will enable us to custom model problems that have very different dynamics. And so we have another program called sort of locally known as food stamps, or Supplemental Nutrition Assistance Program, SNAP. And that was an interesting problem to look at because we found that often many people would drop out of the application process. And sometimes that was because they were part of an at-risk population, whether they were maybe they were an immigrant or they were an elderly and weren't sure about how everything had gone online. And so sort of the first step here is whether or not they're part of that population, and then we found different probabilities of a successful application for people who did an expedited one or a regular application. And then often if people had language barriers, they would need to resubmit. So with this problem, though, we couldn't use a Bayes net because we have people who are dropping out. So we have these asymmetries in the problem that you couldn't represent naturally. And so this is where we're using a more general class of graphs called chain event graphs that let us come in and perform causal analysis and leverage a lot of the Bayes net machinery, but do it in a customized setting. So this is really powerful for this problem. And so then I'll show one more example of how we do this with problems that have different dynamics, also taken from food insecurity. And so this had to do with, again, with this problem of getting meals to kids in the summer. And so we had a series of vendors like Aramark and Revolution Foods, and they are delivering food to a set of sponsors. So this could be your YWCA or your Boys and Girls Club or your school districts. And then those people are actually serving meals to these sites. So it could be an apartment complex or an individual school. And so what we found was that often these are closed. You're feeding the same number of kids every day, but because it's very hard to break even in this program, sometimes one sponsor, it was more financially beneficial for them to take over someone else's sites. So in this model, we want to come in and maybe test what is the causal effect of those interventions. Like what happens if the school district comes in and starts feeding kids at these apartment complexes in addition to the sites they're already feeding. So that's the sort of causal question we wanted to answer. A Bayes net couldn't do it because these meals are conserved at each step. They go from vendor to sponsor and sites, and we don't lose any meals in the process. And so we wanted to conserve that, and so that induces lots of dependencies, and there's mathematical reasons why you can't do it with a BN. And so we came up with, well, I didn't come up with this, but you can look at the flow graph for this. And so what my research is focused on is looking at these different custom graphical models that we have and seeing if we can come up with a general causal algebra that explains how we do this process, where you meet a problem in the wild or in the third sector and you want to do some custom mathematics with it. So I find this really exciting because I think it can be really powerful for decision making. Presenting the decision analysis, it was just really fun because I think often in nonprofit I found I'd work with people who had kind of a pet theory about, oh, if we just could change this. And so it was neat to be able to model that and say, here, you can sort of at least simulate that. And then we could also get a handle on what sort of effect different interventions we're having. And I think it's just exciting that all you guys are here today. So because Warwick for me has definitely been a place where you can come up with new statistical theory motivated by applications. Thanks.